Assalamualaikum and very good morning to all of you. Today, I would like to present my research paper with the title of Effect of Pulse Scouring on Structural Integrity of Fixed Offshore Jacket Structure. As an author of this paper, myself is Abdul Hadi Abdul Hassani, and with also the co-author Muhammad Ferry Abu Hussein, Nurul Izzah Muhammad Zaki, Nurul Azizah Muklas, and Said Zainal Abidin Said Ahmad. Fixed type platform called template type structure, which consists of a jacket or a welded space frame that is designed to facilitate pile driving and act as lateral bracing for the pile. The fixed steel jacket template stability founded on the pile depend on the number one, bearing or pull-out strength, pile lateral behavior, soil liquefaction, and risk of scouring. Due to criticality of the scour, depth prediction is very, very crucial. Improper judgment may lead to a conservative and uneconomic design. This paper is aimed to study the impact of pile performance based on the design and actual scour of fixed offshore platform. Okay. Before we go further, I would like to introduce a little bit on the scour. Okay. Scour can be defined as the removal of seafloor soil caused by wave and current as their agent. Such erosion can be caused by natural geologic process or structural element interrupting the natural flow regime near the seafloor. Scour can be divided into two, which is a global scour and also a local scour. Okay, scour design specification. Okay, the asset owner of the platform, each of them will have a specific design specification where it basically tells you how much the magnitude of the scour that you should consider during the design stage. For example, Petronas, they will specify a minimum of 900 millimeter or one pile diameter size. So let's say if your pile diameter is 1000 millimeter, then you have to use your scour depth at the early stage of design as the 1000 millimeter. So ONGC have 1.5 times the diameter, which is slightly higher compared to Petronas, and Shell adopt the same thing as Petronas, and Saudi Aramco is 1.5 times the pile diameter. So each of them will have different category in determine how much is the magnitude of the scour that you should consider during the design stage. Okay, methodology. Okay, while I'm working on my research paper, so these are the flow chart of my research. So number one, it starts with the data collection and model preparation, and then we move on to the static in place analysis. So where this is the most important part, where we have a scour, which is the design scour value, which is assumed at the early stage. For instance, if you use Petronas technical standard, we have to use a 1000 millimeter as a scour depth, and the actual one is the one that you measured at site after a certain years. And then after that, we run the analysis and then we compare what is the value in terms of value of the pile unity check, the pile displacement, and pile factor of safety. We want to see what is the trend or what is the outcome of the design against the scour depth. After that, we will draw a discussion and conclusion, and then we report it. Okay, the analysis that that I performed during the research is basically static in place analysis with the pile soil interaction. The aim of this objective is to investigate the structure global credibility against untimely failure. So the first thing that starts is basically we have to prepare the geometric model. Okay, the geometric model consists of a jacket on top side, and then after that we have a load simulation where we have to apply whatever the load that actually similar to condition at site, and then we have to prepare the foundation simulation. Is a simulate pile and soil characteristic as per the geotechnical report. And after that, after we have all the three components, then we are ready to perform the pile soil interaction. And after that, we have the result, which is the parameter that we are looking for. Okay. Once we have completed our analysis, okay, there are three parameters that we define as the key performance for the pile, okay, which is the pile unity check, factor of safety, and pile head displacement. Out of this, my study, I will set as a minimum value, average value, and maximum value for these three key parameters. So for number one, as a unity check, so whatever the result came out from the analysis, if it's more than 1.0, it does not comply with the code and standard. A, for factor of safety, it has to be minimum of factor 2. So it's more than 0.2, it's good. Less than 0.2, this is does not comply. So pile head displacement we use as recommended by the specification is 1.0 times your pile head diameter. So that is the maximum. So it is more, basically it's not comply, less than should be comply. Okay, for my case study, I use a fixed offshore platform. It's a 4-legged, pile diameter 1372 and water depth 75.7. So the design scour depth is 1372 and then the actual one measured is 390 after 5 years. So the utilization is only about 0.284. So, okay. From the result, what we can see here, this is 390, the actual one, this is the design. So what we can see for the factor of safety, one pile leg shows the increase while the rest of the pile leg, the 3 number of the pile leg, which is show decreasing when we increase the scour depth. Okay, but for the pile head displacement and unity check, when we increase the scour depth, it basically show increase in pile head displacement and unity check. So you can see more clearer in this plotted graph. So pile unity check, so this is the minimum 0.25. I did some iteration on the scour depth, which is 0.025 diameter, 0.5 diameter, 0.75 diameter, 1 point diameter, because our recommendation given by the code is 1.0 diameter. And then the actual measured is this one, 390. So when we plotted against this graph, we actually the trend shows similar for the 4 numbers of the pile. So they are increasing when the scour depth increase. So but for pile factor of safety, only one shows the increase, but the other 3 show decrease. But the magnitude is very, very small. Pile head displacement also similar trends with the increase of scour depth. The pile head displacement also increased. The reason being is because of the lateral support. When we increase the scour depth, the lateral support of the pile is basically they are lost their lateral support. So bending moment is increased, their lateral significantly, and then due to that also the pile head displacement is also increased. Okay. As a conclusion, this paper has concluded the impact of pile performance based on design and actual scour of the fixed offshore platform has been measured, and the result summarized as follows. Actual measured scour after 5 years was less than recommended scour with utilization of 0.284. The pile unity check at mudline and pile head displacement was directly proportional to the scour depth. The pile factor of safety was inversely proportional to the scour depth for one leg, while the other for one leg. Higher scour value directly impacts the pile UC, pile head displacement, and pile factor of safety, which lead to unnecessary upsizing and deeper penetration. Therefore, it can be concluded that the depth of scour design is very crucial, and a misjudgment of that may lead to a conservative and uneconomic design of the offshore structure, especially where the economic perspective is very, very crucial during nowadays, because most of the client will try to cut costs and try to minimize the cost of the development costs. So with that, thank you very much.